Alright, so here's where we left off yesterday. We may have finished this one in one class, the other class was just at the tail end of it. So I'll review this one and then we'll keep rolling. It says find the remaining roots of the equation. So if this remaining roots, I want to find the leftovers using synthetic division. So 1, 1, -5, 1, and -6. And it does not matter which of these two roots. And now we know they're roots because they said that, which means I can use either one. I'll start with 2. You multiply to go up, and then you add. And then we multiply, and then add. Multiply, and then add. Multiply, and then add. And this has to happen every time if we're looking for the remaining roots, because, and if, actually no, if they are roots. If these numbers are roots, that means it's a factor, which means that the remainder is always going to be 0. If you don't get 0, that means you got to recheck it and redo it again until you get 0. Okay, now I had 1, 2, 3, 4, 5 terms. I broke out an x value, so now I'm down to 1, 2, 3, 4 terms. I'm going to try to break another x value out of there. But I just keep on doing synthetic division. Okay, you multiply and then you add to go down, and then you multiply and then you add, multiply, and then I add. And again, I got a remainder 0, which is awesome. So then from this step, this is an x, this is an x squared. So I'd have x squared plus 1 equals 0. And then I got to solve that or factor that. Now that doesn't factor because that's not the difference of two squares, this would be the sum. So I can't factor, but I can just move the 1 over. And I get x squared equals -1. And then after that, I can square root, and x equals plus or minus square root of a -1, we know is I. So there's two answers there. Here's number 3, and there's number 4. Okay, and that is the 4 solutions or roots on this problem. All right, next one here. Solve that equation. Okay, so if I'm going to solve it, you always set it equal to 0, which means I will have 2x cubed plus 2x squared minus the 4x and minus the 4, because you're going to minus them to the other side. And then that's going to give me 0 on this side, because these will cancel. Okay. And now how many terms are up here? 4 terms. So if there's 4 terms, we can't factor that like a trinomial, where you do 2 sets of parentheses. 4 terms is called factor by grouping. Okay, so I'm going to group these 2, and I'm going to group those 2. Okay, what's common in the first set? A 2 and an x squared. And I'll be left with 2 times 1. And then just an x there actually, so 2 times x, 2x squared times x would be 2x cubed. 2x squared times 1 gives me 2x squared. Okay, what's common in the second set? A -4. And then what am I left with? -4 times x gives me -4x. -4 times a positive 1 would give me a -4. And what has to happen with factor by grouping every single time here, which was awesome, it did here. My computer wants to go here. Okay, that has to happen every single time, so since it did happen, I'm going to take that common term, I'm going to bring it out in front, and the leftovers are going to go in the second set of parentheses. So the leftovers will be the other 2 parts. Now it does say to solve here, which means I need an actual answer. So this answer, we set it equal to 0, would be x equals -1. On this one here, I got to go 2x squared minus 4 equals 0. And then just solve for x. So I add the 4 over. So I get 2x squared equals 4. Divide by 2 next. So I get x squared equals 4 over 2, which is 2. And then my last step is to square root. And how many answers do we get here? 2 of them, plus or minus square root 2. Okay, and how many answers should have I gotten in this problem? 3 of them. So those are 3 zeros of the function, or 3 spots where that graph will cross the x-axis. Questions on that? Alright, next question here. Solve and graph each inequality or equation on a number line. Okay, so gave you a number line on the test. So there's a couple things I could do here. I don't like fractions, so I want to get rid of them. So what you can do is you can find a common denominator, number 1, if we want to do that, which would be 15. So if I multiply this side by 15, I can also multiply this side by 15. Okay, and then I can cross cancel here, so 5 goes into there once, 5 goes into there 3 times. Okay, now what am I going to do with that 3? I'm distribute it in there, so it'd be 6x minus 18. Alright, next question here, so now 3 goes into there once, 3 goes into 3 goes into 15 5 times. What can I do with these guys? That's 10. So what am I going to do with that 10? Distribute it in. And that gives me 20x plus 10. And then letters on one side, numbers on the other. So minus 6x, minus 6x. That gives me 14x plus 10 and negative 18. And then minus my 10s. And then I get 14x is less than or equal to negative 28. And I divide by 14. And x. And then negative 2. And there's an open dot or closed dot at negative 2. And on this one it would be closed. And the arrow goes to the left in that one. Okay. Alright, next one here, solve each inequality. So the question here says, where is this whole equation, graph, less than or equal to 0? What does less than 0 mean? In the negatives? So what I gotta do here is I gotta take my calculator out because I gotta visually see what the picture looks like. Okay, so the question is where are the answers here negative or equal to 0? So go to y equals 2 sets of parentheses. We're going to go 2x plus 1 and then x minus 5. Close off the double set of parentheses and then divided by, and then parenthesis x minus 3 in parentheses and then cubed. Okay, let's graph it and see what it looks like here. Now I got an asymptote, I bet you here. At what number? 3, yep. So let's see what's going on here. Okay, well, if I go to second format and I take my axes off so I can see what's going on here, and then hit graph again. Okay, it's coming across, and then it tails up again. So it looks like it's below or right here. It's getting lower here, and then it gets higher again. So it's high, it goes low, it goes high, and then it goes up, and then it comes down and goes around. Okay, I'm going to go back to second format, and I'm going to turn my axes back on. Okay, and now where are my crossings at according to my 3 zeros of the function here? Well, 5 would be 1. Set that equal to 0, you get negative half. And then 3. So if I think about it on my number line here, I know my asymptote would be at 3. Okay, so you gotta draw this out so you can visually see it. It crosses at 5 here. And you can see over by the picture, it looks like it comes up from here, comes through at 5, and then it kind of goes like this, so it's a crossing at 5. And then the other crossing is at -0.5. And by the looks of it, I'm guessing if it crosses at -0.5, so 3, 0 is here, 1 is here, so -0.5 would be right there. It looks like since it's below here, I'm guessing it just goes below and then it hovers back and touches the line. So technically, it's like touching the line here. It maybe goes down a little bit here, and then it comes up through here, and then it goes straight up. Okay, it does not cross any more times though, because these are the 3 spots where things are happening. Okay, so it crosses at -0.5. It crosses at 3 there, or it's an asymptote at 3, and then 5. Alright, so we gotta ask ourselves, where is this function? Less than or equal to, which means where is it negative? Okay, so if I look here, where are the spots where it's negative? Well, other than green here. From here, from the asymptote to here, it's below the x-axis, so it's negative in that section. So I would say, how would I say it? It's in between these two numbers. 3 is less than x, which is less than or equal to 5. Okay, because it's below between those two spots. And where else is it below? Looks like it's below from here to the left. Anywhere from there to the left. Or equal to 0, because it can be equal to 0 too. So then x is less than or equal to -0.5. And that would be my solution. Alrighty. Graph the solution set of each system. Okay? So on this problem here, I'm going to have to, again, use my calculator so I know where some stuff is at. So I got a -x squared plus 4x. Let's graph that and see what happens here. Okay, so it looks like it crosses at 0 and 4. If you were to factor out an x, it'd be -x plus 4. And if you set each one of those equal to 0, it'd be x equals 0, or -x plus 4 equals 0. And minus the 4 over. You get -x equals -4, so x equals 4. So it does cross at 0 and 4. You could also go second calculate the zeros of the function. You need to mark these properly. So at 0 and 4 is a crossing. I need to find the maximum here, where that peak is. So second calc, the max. Okay, left bound, hit enter. Right bound, go over the peak, hit enter, and then enter. Alright, so we got 2, 4. So 2, 4 is my other crossing. And is this a solid or dotted? Okay, it'd be solid because it's equal to. Okay, so now I label all the parts I need there. Next up here, how do I read this? Y is what? Less than. So that shading would be at this point below. So anywhere below. And then I got to graph this line here next, so I'll go blue for the line. What's the y-intercept on that line? -3. And the slope is up 2 over 1. Okay, or down 2, back 1. So I got my line and it's solid. It's equal to. And this says y is greater. So greater would mean up. So where are they sharing their common shaded region? And it'd be right here. And that's my solution here, which is graph the solution set of the system. Alrighty. Which one of these two functions has an inverse? So we gotta pick which one has an inverse, and then find the rule for the inverse and explain why the other function does not have an inverse. Well, so to check if some equation has an inverse, we can actually plug it in my calculator. So if I go second square root of 9 minus x squared. Okay, and I plug in my calculator and graph it. There's a test we do for inverses. It's called the horizontal line test. So if it crosses more than twice when you draw a horizontal line through it, it is not an inverse. So if I look here and this is like a half circle, if I drew a line through that half circle, so it looks like this. So if you do the horizontal line test, does that cross more than once? And it does. So this one here does not have an inverse. So instead of explain why the other function does not have an inverse, you can say it doesn't pass the horizontal line test. You could also try to do the switching of the x's and y's, and it won't give you an x in the end when you get to it. Alright, let's try. So I know that's part B now, so I answered part B. Let's do part A. Which of these two functions has an inverse? This guy's the one that does. Find the rule for the inverse, or find the inverse. So g of x is the same as what letter? Y. So y equals 2x minus 3. And again, that's just a line, so if you plug in 2x minus 3 into your calculator and graph it, it does pass the horizontal line test, only crossing one time. Okay, so inverses reflect over the line y equals x. So what do I do with these then if you reflect over the line y equals x? We switch the y and the x. And then what letter do I solve for? Y, because we always solve for y. Okay, so I'll add 3 to both sides, which gives me x plus 3 equals 2y. And then you divide both sides by 2. And we get y equaling x plus 3 over 2. And if I actually write it as the inverse, we use the g of x thing, but we go g to the negative 1, g inverse of x equals x plus 3 all over 2. And there would be the rule. Okay? Alright, next question. The graphs of the periodic function y equals g of x are shown at the right. What is the fundamental period? What are the maxes and mins? And what is the amplitude? Okay, so we got a picture here. Not a spectacular picture, but a picture nonetheless. The graph of the periodic function is shown at the right. It's actually shown below here. Okay, what is the fundamental period? So where does this thing start and stop? So where's the pattern? If I look up here, I see a pattern of a big mountain thingy with a plateau, and then a little spike. And then it repeats right here. So it started here, and it repeats here again. Big mountain plateau thingy, little spike. So there's like 2 of them. So how far, and let's say now, it's hard to measure from here to here. Could I measure from maybe this right peak of that plateau to this right peak of that plateau? So it'd be what? 1, 2, 3, 4, 5. So what is the fundamental period? 5 would be the fundamental period of that function. Okay, so every 5 it would repeat. Yep. Okay, what are the maxes and mins? So what is the highest? The maximum would be 1. What is the minimum here? The lowest would be negative 3. Okay, and then it says what is the amplitude of g, and the formula for that was max minus min divided by 2. So max minus min divided by 2. Negative, negative, make a plus here, so that's a 4 over a 2, which turns into 2. So my amplitude of g is going to be 2. All right, next one here. Give the domain range and zeros of the function. So what I need to do here is again use my calculator because I need to visually see what it looks like so I can give the domain, the range, and the zeros. So square root of x squared minus 16. Okay, and then hit graph. Alright, so it looks something like that. Now on your calculator, I know you guys' calculators aren't touching here. It actually is touching for you. If you look up there, what numbers does it look like it's touching at? -4 and 4. Now to know if it's touching or not, if I plugged in a 4 here, what's 4 squared? 16 minus 16 is 0. And can I take the square root of 0? And if you don't know, you just plug in your calculator. You can. 0 times 0 gives me 0. So therefore I know it touches. So it touches here, and I know it touches there. And it goes off like this, and like this. So since it goes off in those directions, how do I say the domain, which are the x values that are showing? So my domain, it's showing everywhere to the left of -4, so that's x is less than or equal to -4, or x is, which way is this showing? To the right, so greater than or equal to +4. That's my domain. Okay, the range, the y values that are showing. Well, is there anything below the graph here? Nothing below. So it's everything above the x-axis, and if it's the range is the y's, I'd say y. If it's above means greater than or equal to, and then 0 is the height, because at 0, it's from 0, and then it goes up forever. Okay, and then what are the zeros of the function? Well, the zeros are where it crosses, so the zeros on this problem would be at x equals 4 and -4, because those are the two spots where it's touching here. Okay? Alright, we got last problem here. So here is my 4 functions. 3 functions right here. Okay, so we're going to do an f divided by g, and f minus g of x, and then an f circled g. And we got to find what they turn into. And I gave you the equations up here. So let's do the division one first. Now when you guys do division, now remember, does this x matter when you guys do these? It doesn't, it just tells me which one's the function up here. So therefore, I forgot f divided by g, f is going to be x squared minus 3x plus 2. And we're going to divide by g, which is this guy. So x, not plus, x minus 2. Okay, so when you guys are doing these, I need to type them in, and with a fraction we need to think about factoring on the top. Okay, so I got to think about, well, what can I factor the top into? Now this one isn't just a common term, so it's a trinomial, 3 parentheses. I'm going to leave the bottom as x minus 2. So what times what gives me the first term? X and x. If you ain't first, you're last. So then my last terms would be 2 times 1 gives me 2. And will those add to give me -3? And they will. If you check the outside and the inside, the outside gives me -1x. The inside is a -2x. And that does get to -3x. Okay? So I factored correctly now, and can I cancel now that I have an x minus 2 and an x minus 2? Yes. So therefore my answer on this problem is x minus 1. Okay, next one here we got f of x minus g of x. So the f function, which is in red here. So x squared minus 3x plus 2. And we're going to minus. Now here's the key thing you got to remember. The g function, which is x minus 2. On the review I said to remember it, but I forgot to actually distribute. So I need to distribute that into here and here. So now x squared minus 3x plus 2 minus x plus 2, which gives me x squared minus 4x plus 4. And there's no more like terms, so then I'm done. Okay, and the last problem here, f circle g of x. How do you rewrite f circle g of x? It's the same as f of g of x. So what's on the inside? The g of x is on the inside here, so you're going to take g of x and you're going to plug it into the f function. So I'm going to take my g of x, which is green, and plug it in to my f function. Now you got to plug it in how many times here? Twice, because there's an x here and an x here. So if I rewrote this, it's x minus 2 squared. So x minus 2 squared, and then a minus 3 parenthesis, minus 3 parenthesis x minus 2, and then it's plus 2 at the end of that red one. So then a plus 2 here. Okay, and then we got to simplify. What's it mean to square something? Take it times itself. Okay, I could take this negative 3 right now and distribute that in there, so I get negative 3x and a positive 6. Okay, and then we're going to do what with these two parentheses? FOIL. So x times x is x squared, negative 2x is the outside, negative 2x is the inside. Negative 2 times negative 2, positive 4. If you don't use something, we bring everything else down. Okay, and then we can combine like terms here. So we got x squared, negative 2x, that's negative 4, plus another negative 3 is negative 7x. We got 4, we got 10, 12. And that would be final question for this really good study guide for the semester final. Okay, if you want to watch YouTube again, I guess, before this final, you are more than welcome to study up and make sure you know how to do all this stuff. Good luck.